Hi guys. Okay, we will continue on with our exploration of number systems and converting between them. And you'll recall from our previous video, I showed you how to convert from a number in any other base, and we used base 2 and we used base 16, and how we converted them into a decimal number. So I'm going to show you now the other way. Okay, here we are going to start with a decimal number, and we're going to convert it. In this first section, I will show you how to convert to a binary. So we're going to start with a decimal number and we're going to convert it to a binary number. So I'm just going to come up with a number, let's say 17. Okay, so we're going to take the number 17 and we're going to convert that into a binary number. So how we do that is, because we're working with binary, we are just going to successively divide by 2. So here we go. So 2 into 17 goes 8 times. Okay, 8 times. 8 2s are 16, so I've got a remainder of 1. So 2 went into 17 8 times, remainder 1. So now I do the same thing again. 2 goes into 8 4 times, remainder 0, because 4 times 2 is 8. I do the same thing again. 2 into 4 goes 2 times, remainder 0. 2 goes into 2 times, 2 goes into 2, 1 time, remainder 0. 2 goes into 1, 0 times, remainder 1. So now I've ended up with 0. I've got to the end of the process. And now what I do is I read my remainders in reverse. So the answer is 10001. So 10001. That is 17. Okay, so the number 17 is that in binary. We've got to put a little 2 at the end here. Okay, let's pick another one. This time I'll pick, let's say, the number 23. So let's say 23. Same thing again. We're converting to binary. So 2 goes into 23 11 times with a remainder of 1, because 11 2s are 22 and we want 23. 2 goes into 11 5 times, remainder 1, because 5 2s are 10, 1 left over. 2 goes into 5 2 times, remainder 1. 2 goes into 2 1 time, remainder 0. 2 goes into 1 no times, with a remainder of 1. Now I can read my remainders in reverse because I've got to 0 here, and I end up with 10111. 10111. So that binary number there is equal to 23. So that is how we do it. Okay, we're just going to take the decimal number and we are just going to continuously divide by whatever base we want. In this case, it's binary, so I'm dividing by 2, and I write down my remainders. And when I get to the end, I just read my remainders off in reverse. That's the key. Okay, reading the remainders in reverse. Okay, let's have a look at how hexadecimal works. Same thing. Let me just go and grab a pen. Okay, so let's pick another. We're going to pick another decimal number, and this time we're going to convert it into hexadecimal, base 16. So let's pick, let's say 495. So let's say 495. That's our decimal number, and we want to make it into a hexadecimal number. So here we go. 16 goes into 495 30 times. You will obviously need a calculator to do this. So 495 divided by 16 gives me 30 times, and I've got a remainder of 15. So 30 times 16 plus 15 gives me 495. So let's do it again. 16 goes into 30 one time, and this time I've got a remainder of 14. So it goes in one time with a remainder of 14. So let's go again. 16 goes into 1 no times with a remainder of 1. So I have finished because I've got as far as the 0. So what do I do? Well, you must remember we've got hexadecimal numbers here. So the number 14, you will recall from yesterday, is an E. So I can replace that with the symbol E. And 15, you'll recall from yesterday, is an F, because remember, hexadecimal includes A, B, C, D, E, and F to give us our 16 symbols. So now what I do is once I've replaced them, I just read my remainders in reverse, and I've got 1EF. 1EF. So 1EF in base 16 is equal to 495. Well, let's try another one. Okay, let's maybe pick a bigger number this time. So I'm going to pick, let's say, 22317. So let's do that. 22317. So there's a decimal number, 22317. Let's convert that. So we pull out our calculator, and if we divide 22317 by 16, because remember we want to convert to hexadecimal, so 16 is the base. I'm going to get 1394. That's how many times it goes, and I've got a remainder of 13. Okay, you should be able to calculate these remainders. This is primary school maths we're doing here. Okay, you've done dividing and remainders. You've done that, I think, right since probably grade 4. So 1394 divided by 16 gives me 87. And this time I've got a remainder of 2. So 16 times 87 plus 2 gives me 1394. 87 divided by 16 gives me 5. And I've got a remainder of 7. So 5 times 16 plus 7 gives me 87. Right. 16 goes into 5 no times with a remainder of 5. Now I know I've now finished because I've reached 0 at the bottom here. So I can replace my 13, okay, with the symbol D, because we know that 13 is a D. And then I just read my remainders in reverse. So I've got 572D. 572D. So 572D hexadecimal is 22317. Okay, so that is exactly how you do it. You just do successive division until you get as far as 0, and then you just read all your remainders in reverse.